Hey scholars, today we are learning about differentiating polynomials with the power rule. So the goal is that the student will be able to differentiate a polynomial function and use that differentiated equation to find the instantaneous rate of change at a specific point. So, derivative. What is a derivative? The derivative is an equation that can be used to calculate the instantaneous rate of change at any point on a curve. So let's say we have a curve. I can use a derivative to find the rate of change at any point. So let's say I want to know the rate of change at this point right here. I would use a derivative to find that. There's a few ways that we pronounce derivatives. Sometimes we call it f prime of x. This is a derivative. Sometimes we say dy dx. That is another way to say derivative. Or depending on the variables, we might say dv dt, ds dt, whatever variables we use. So what I need y'all to know is the power rule. The power rule can be used to find the derivative. So let's say this is our original function, f of x equals a times x to the power of n. In order to find the derivative, we use this function that says f prime of x, so that's our derivative, is equal to n times a x to the power of n minus 1. So let's zoom in here with my first example. Here I have f of x equals 3 times x to the power of 5. So looking at this here, the a is the number in front of the variable, and the n is the number in the exponent. So here, 3 is the a, and 5 is the n. Now that I have labeled my numbers, I can use this formula of a derivative. So my formula of a derivative says that f prime of x is equal to n a x to the power of n minus 1. I just copied down the formula. Now I'm going to plug in my values. So I have f prime of x equals, n is 5, so I have 5, times a is 3, x to the power of n, 5, minus 1. Now I can simplify. 5 times 3 is 15. 5 minus 1 is 4. So I'm simplified and I'm done. So let's write out what we did here. All we did was we plugged in the values for n and a, and then we simplified. So let's try another one. Here there's no number in front of x, so we have an invisible 1. So a is 1. And here is 17. So f prime of x equals n times a. So I have 17 times 1, x to the power of n minus 1. So I have 17 minus 1. Okay, I'm ready to simplify. 17 times 1, well that's just 17. 17 minus 1, well that's just 16. Okay, I'm done. Easy as pie. Let's try C and D. You try on your own first, pause this while you do it, and then press play. Okay, so for this question, I have a is 2, n is negative 3. So when I plug it into my power rule formula, I have f prime of x equals negative 3 times 2, x to the power of negative 3 minus 1. Negative 3 times 2 is negative 6. Negative 3 minus 1 is negative 4. Be careful when you're adding and subtracting those negative numbers. All right, a is 15. Here there's no exponent, so there's an invisible 1 for my exponent. So f prime of x equals 1 times 15x to the power of 1 minus 1. Let's simplify. 1 times 15 is 15. x, 1 minus 1 is 0. Okay, but this time we can actually simplify further. The reason we can simplify further is something called the zero exponent rule. All right, the zero exponent rule states that any number to the power of 0 is equal to 1. So let's say I have 3 to the power of 0. Well, that's going to equal 1. What if I have 100 to the power of 0? That's going to equal 1. What if I have x to the power of 0? That's going to also equal 1. So here, f prime of x equals 15 times x to the power of 0, which we just said anything to the power of 0 is 1. So we have f prime of x equals 15 times 1, which is just 15. Okay, we did all of that work for part D to just end up with 15. So we're going to use this as a jumping off point for the special case, linear terms. That's anytime you have just a number in front of the variable with no exponent or an exponent of 1. We don't have to do all that work to know that the derivative is 15. We could have just looked at it, seen that the exponent was 1, and just immediately known, okay, derivative must be 15. So here it's the same thing. If d of t equals 3t, remember there's a power of 1 here, so we can automatically know that the derivative is just going to be equal to 3. If h of z equals negative 17z, then h prime of z is just going to be negative 17. So whenever you've got that invisible exponent of 1, the derivative is just equal to the coefficient. It's just equal to the m. Let's look at another special case, constants. This is whenever we have a function where it's just equal to a number. So anytime that is just equal to a number, the derivative is just going to be 0. So here, s prime of t equals 0. G prime of x equals 0. The reason is these are constant terms. This 7 and this 52, these are constants. They're just numbers. Just numbers. Okay, the reason is because let's envision a graph, and let's say the equation is f of x equals 2. Well, we use y to represent f of x, right? So f of x is 2, that's just the same as y is 2, which is just going to be a flat line here. And notice that the gradient at any point on this flat line, the gradient is equal to 0. And since the derivative is the way that we calculate the gradient at any point on a curve, if the gradient is always 0, then the derivative is also just equal to 0. And level 2, we are going to skip level 2. Don't worry about that for now. We're going to go right on to level 3 when we have multiple terms. So the way that we deal with multiple terms is we just do each term on its own. So 2x to the power of 7, I'm just going to look at that as an isolated unit, and I'm going to use my power rule. So I have 7 times 2 to the power of x to the power of 7 minus 1. All right, now I'm ready for my next term. So I have plus 3 times 1x to the power of 3 minus 1. Then I have my next term, minus 2 times 9, x to the power of 2 minus 1. This is a linear term. There's a 1 in front of it. So I'm just going to use my linear terms rule, which just says that the derivative is just going to be 1. This is a constant term, the 7, and we said that that's, when we take the derivative, it's just equal to 0. So I can put plus 0. All right, now we can simplify. So 7 times 2, that's 14. 7 minus 1, that's 6. 3 times 1, that's 3. 3 minus 1, that's 2. 2 times 9 is 18. 2 minus 1 is 1, which is just x to the power of 1 is just x, so I'm just going to leave it at that. Then we have plus 1, and then I don't need to write plus 0 because it doesn't change the value. So I'm done here. Okay, now I want you to go do your delta math. Woo!